We're going to start by just reviewing mechanical advantage ratios. Again, like we mentioned last time, 1 is the magic number. Okay, if mechanical advantage is greater than 1, then less effort force is required to overcome the resistance. For example, here, this elephant may weigh, a ton or more, very, very heavy. Well, how on earth can a person lift an elephant? They can't possibly lift it normally, but if you use a rope and pulley system, then they can use less effort force than the actual weight of the elephant. The drawback, though, is that they have to move a much greater distance. So you might have to pull the rope many, many feet in order to get the elephant to move up just 1 inch. If mechanical advantage is less than 1, that means that greater effort force is required to overcome the resistance. The example right here is tweezers. Okay, well, we use tweezers because if I were to use my fingers to remove a splinter, just the force of my fingers might break the splinter. Okay, and then it might get stuck in there, and then it hurts. All right, so we use tweezers to produce a mechanical advantage of less than 1, so that way when I'm pressing on the tweezers with lots of force over here, press with lots of force here, then the ends of the tweezers has less force, very little force here, so that way I don't break the actual splinter, right? Less effort distance is required in order to overcome the resistance when mechanical advantage is less than 1. Mechanical advantage can never be negative and also can never be 0. Actual mechanical advantage, again, this is a review, is based on inquiry or experiment. Frictional losses are taken into consideration, and we use AMA to calculate efficiencies. AMA is the magnitude of resistance force, FR, over the magnitude of the effort force, which is FE. Magnitude meaning just a number, don't care about the direction. Ideal mechanical advantage, or AMA, is based on theory. Friction losses are not taken into consideration, so that's how it differs from AMA. It's the ratio of the distance traveled by the effort over distance of the resistance, and we use it to calculate efficiency as well as safety factor. Can you think of a machine that has a mechanical advantage of greater than 1? One example is a windmill. Can you think of a machine that has a mechanical advantage of less than 1? Well, an example is resistance machines that you might see in a gym.